Hello. Here, I am starting with a revision of the first topic of the 11th standard, that is basic concept of chemistry. So, mostly in this lecture, I'll be doing extensive numerical solving. That is a major part. Okay, main purpose of this lecture is to do numericals, whatever is there with respect to basic concept of chemistry, like which will likely to come in your first mid test. So here, the concept. Let's understand something about the thing. Mm, Before I start, I want you to understand what is the atomic mass and mass of one atom. Okay, so atomic mass, and a second thing is mass of one atom. Mass of one atom. Are they same or different? Answer is clearly they are different. Atomic mass, by definition, what I will say is that it is a mass of mass of 6.023 into 10 raised to power 23 atoms of particular atom. Mass of these many atoms, 6.023 into 10 raised to power 23 atoms. And let's understand this, what is the mass of atom later. So, for example, when we say atomic mass of hydrogen, simplest element, it is 1 gram per mole. This is the unit. Means whose mass it is? It is a mass of 6.023 into 10 raised to power 23 atoms of hydrogen. This number is very big. Okay, very big. You can see that 10 raised to power 23. It is this big. Point is here. 1, 2, 3, 4, 5, 6, 7, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. It is this big number, right? So when these many atoms of hydrogen will come together, it will weigh how much? 1 gram. Same way, if we do for the like carbon, I'm taking some random values. Carbon's molar mass is 12 grams per mole, means it is a mass of 6.023 into 10 raised to power 23 atoms of carbon. When these many atoms of the carbon will come together, and whatever is the weight of those many carbon, that is a weight, what we call as a molar mass of the carbon. See, molar mass is like definition of the molar mass is constant. It is a mass of these many atoms of a particular atom, right? So if we take nitrogen's mass is what? 14 gram per mole, means it is 6.023. It's okay to take this to be 6.022 or 6.023. I am just taking this 23 because this is also 23 and this is also 23, right? So we'll take this to be 22 only. 6.022 we'll take this. When you solve numericals regarding a competitive exam, there it won't matter much, so we'll write this. So this is atoms of, here also I'll change. So this is 23. So these many atoms of nitrogen will come together. That time it will weigh 14 grams. See, mass of atom, one atom cannot weigh in gram. It is very, very small, right? So nitrogen 14. Now if you take a sodium's atomic mass is 23. This is the value which is given, okay? And it will be always provided to you in exam. Remember this. Atomic mass is, this is equal to 6.023 into 10 raised to power 23 atoms of sodium, right? So what is this? This value which I have written over here, this is equal to, is equal to 1 mole. We call this to be is equal to 1 mole, or this value is also is equal to 1 mole, right? We say a 1 dozen is equal to 12 units. Same way, Here, this big number is equal to 1 mole. So why big number? See, in a small amount, basically what we need to do is we need to count the atoms. We have to know the, not count, we have to know the what is the number of the atoms present in a given species. Let's say very little amount of the sodium is there. Only this much of the amount of the sodium is there. How many atoms will be there that we have to know. If we just write this big number, our calculations will become difficult. So we deal in moles, right? So that is what the idea, whole idea. If I say that there is a small block of iron, then how many atoms will be there in that small block? So we can say that many mole, these many mole, like the way we deal in dozen. Okay, so this is the idea about the atomic mass. Now I'll put one simple question in front of you. We'll make these things clear here only. Um, like which example we'll take? We'll take the example of we'll take a carbon. Okay, we'll take a carbon. Uh, atomic mass of carbon is 12 grams per mole. See, the units of the atomic mass is grams per mole, means these many grams per mole, means it is a mass of what? 6.023 into 10 to 23 particular atoms, right? So that is per mole we are writing. So atomic mass of carbon is 12 grams per mole. So what is the question? Calculate number of atoms present in um, let's say 24 gram of charcoal. Okay, charcoal means it is carbon. So what do we know about the molar mass? How to get this? See, yeah, there will be a different formulas. Of course, you have to uh, know the formulas, but sometime what happens is that we tend to forget the formulas, right? So we have to know the concept also. What does this mean? So we'll have a standard relation. Calculate number of atoms present in a 24 gram of carbon. I have told you to calculate the number of atoms, right? So let's understand this. We should have some standard relation. What is the standard relation? That a 12 gram of carbon or a charcoal, we can say, because charcoal is also a carbon. 12 gram of carbon is weighing how much? How many atoms are there? I will equate this with what? Number of atom. It has 6.022. It has 6.022 into 10 raised to power 23 atoms. So how many atoms will be there in a 24 gram? 24 gram of carbon will have x atoms, x atoms. So this is, I am using a method of the cross multiplication. Okay, this is something which you should know as a science student. You should know a basic idea about the cross multiplication. We take the help of standard relation, then we equate this. Okay, you can use a formula also. No doubt, no doubt. You will end up with the same thing. You'll end up with the same thing. Even if you are using a formula, you are ending up with the same thing. So what is the cross multiplication over here? So I'll multiply this and this, and I will put equal to this multiplied by 24. So x into 12 will be is equal to 6.023 into 10 raised to power 23 into 24. So what is x is equal to 6.023 into 10 raised to power 23 multiplied by 24 divided by 12. So this is the thing which is getting cancelled. So x is equal to 6.023 into 10 raised to power 23 multiplied by 2, which is equal to 12.046 atoms of carbon. Almost it, sorry, into 10 raised to power 23 is there? Yes. 10 raised to power 23 atoms of carbon are present in a 24 gram of charcoal, right? So this is the whole idea. You are told to find the number of atoms in 24 grams, right? So formula will be what? When you are told to find uh, atoms in a given amount, like this is something fixed. This is what you take. So number of atoms will go to formula. Will go to formula. Uh, let's understand this. Okay, we'll write the formula. So this X represents what? Number of atoms in given quantity. Number of atoms in given quantity. What is this? Avogadro number. This is constant 6.0223. See, yeah, I am using this 2322. Uh, we'll do this 2 2 2, and here it is 4 4. So this is 6.022 into 10 raised to 23. What is this 24? 24 is a given mass upon what is this? Molar mass or atomic mass. I'll use this one, atomic mass, right? So this is the thing. So this is like your formula. This is like your formula. You can stick to this. Next question I'll ask, what is the what is the number what is the number of moles of carbon present in um 24 gram of charcoal. Charcoal means it is a carbon, a bunch of carbon, right? So now the question is number of moles. Like earlier it was like I'm asking you exact number, and I ask you like 24 bananas are there, or 48 bananas are there. First I'm asking how many bananas are there. You count each and every banana, you say that it is 48 bananas. But if I ask you what is the number of how many dozens are there, you make 12 is equal to 1 dozen, and you say that it is 4 moles, right? Sorry, 4 dozens of banana. Same way here moles is asked. So we have a standard relation. See how my standard relation is changing now. Standard relation is 12 gram of carbon. Since we are told to find the number of moles, I'll change this to what? 12 gram of carbon is equal to 1 mole atom of carbon, right? And how many moles are present in 24 gram? Is 24 gram of carbon. We can put this arrow or equal to sign, no issue. Equal to sign, I'll put 20 gram will have x mole of atom of carbon. Isn't it very simple? So x is equal to what? X into 12 is equal to 1 into 24. So what is x is equal to? X is equal to 24 by 12. So I'll tell you what is the x. X is over here. X is telling you about the number of moles. We know this number of moles. X is moles of atom of carbon. X mole atom of carbon, right? So number of moles, it is represented by small n. What is this 24 in this question? What is 24? 24 is the molar mass, or sorry, given weight. This is what a 24 is, the given weight. So you write this given weight. And what is this? 12 is what? Atomic mass, right? Are we not coming to the same formula? This is what? Given weight. If we relate it, given weight, and this is what? Atomic mass. So formula, there are chances that you may forget that when we go in an examination hall, what happens is that number of moles, we may write atomic mass upon given weight upon atomic mass. But if you know the concept, you can just go through this. You can swim through this very nicely, very easy. It is not a very big rocket science, right? So this is a formula which you always by heart. No, you tend to by heart this formula. Of course, you can by heart this formula. Formula will always help you for a quick access. It will easily you can easily use formula and get the answers. Okay, this is the formula. This is the trick. Okay, in case you forget the formula. This is the thing. Now, next question will be, I'll be asking, what is the mass of one atom, one atom of carbon? Do we know the mass of, like how we will form a standard relation? We know the mass of these many atoms, 6.022 into 10 raised to power 23. These many atoms will weigh how much? Means this will be the mass, atomic mass, no? These many atoms will weigh 12 grams. 12 gram. So 6.023 in 10 raised to 23 atoms of carbon weighs how much? 12 gram. So what is the mass of one atom of carbon? It is equal to what? It is equal to x gram. So what is that x gram? X will be is equal to, you will multiply this x into 6.022 into 10 raised to power 23 is equal to 12 into 1. So x is equal to what? 12 upon 6.023 into 10 raised to power 23. I will cancel this approximately. This is twice. So 2 into 10 raised to power minus 23. This is in the denominator. It will go in the numerator, right? So I am canceling, like this makes sense, no? Like 2 into 10 raised to power 23 is very, 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 very less weight, no? That could be the mass of atom, right? One atom of the carbon. So what would be a formula over here? Mass of one atom, mass of one atom. Formula will be what? If you are sticking to a formula, then mass of one atom is what? What is this? What is this? 12 I have written over here, which I have cancelled. 12, which I have cancelled later. It is atomic weight, atomic weight upon Avogadro number. Avogadro number. This is known as what? Avogadro number, no? So mass of one atom is atomic weight upon Avogadro number. You can do this also. You can use this formula happily, right? Isn't it very simple, right? So let's, based on these concepts, let's solve some question. Okay, one more thing I'll make clear over here is that many students get confused with atomic mass, molar mass, molecular mass. See, these are the terminologies you are going to encounter. One is atomic mass. You should be very much clear with this. Other is molecular mass, and other third is molar mass, atomic mass, molecular mass, and the molar mass. There is nothing to worry about this. It is very simple. It is very simple. Atomic mass, molecular mass, and the molar mass. Um, we know that atomic mass is a mass of one, or mass of 6.023 into 10 raised to 23 atoms. What is a molecular mass? It is a mass of 6.023 into 10 raised to 23 molecules, right? Means let's take a example of the water. Let's take the example of the water. H2O. H2O's molecular mass will be what? Um, it is 18. 18 means 2 into 1 plus oxygen is 16. Two hydrogens into 1. So this comes to 18 grams per mole. And molar mass. So I'll consider here, I'll write carbon is having 12 grams per mole. What is the meaning of this? Molecular mass. Molecular is with respect to molecule. Again, it is 6.02 into 10 to 23. Let's say there is a glass of water. There is a glass of water, and inside this water, this is water. This is how the water will look, right? Let's say this is water, and this weight of this water alone, water is 18 gram. 18 gram means what is this? There are how many? molecules of water, there are 6.023 into 10 raised to power 23 molecules of water. Molecular mass is again same. It is a 6.023 into 10 raised to 23 molecules. Now, what is a molar mass? What is a molar mass? What is the meaning of this molar mass? I'll make some statements over here. I'll make some statements. With that statements, I think you should be able to understand the molar mass. I can say I can say understand this. Huh? I can say that um, atomic mass of carbon is 12 gram per mole. Atomic mass of carbon, I can say this way. I can also say that molar mass of carbon is 12 grams per mole. My both these statements are correct. Atomic mass, atomic mass of carbon as well as molar mass, because molar mass means what? Mass of one mole. No, we are using a mole over here. That's why molar mass. I can also say that I cannot say this. I cannot say this. Molecular mass of carbon is 12 grams per mole. I cannot say this. Molecular mass of carbon is 12 grams per mole because carbon is not a molecule. It is a atom, right? Molecule is a group of atoms of the same type or of the different type, right? I cannot say this. Now I'll make one more statement regarding of water. So here I can say that molecular mass of water or H2O is 18 grams per mole. I can say molar mass of H2O is um, 18 grams per mole. Why I can use this molecular as well as molar? Because it is again a one mole. See, I can use molar here also for atoms. I can use molar for molecule also. But I cannot say this statement. We cannot say it. What? Atomic mass. Atomic mass of H2O is 18 grams per mole. We cannot say this. We can say this first statement, second, and we cannot say this because water is not a molecule. Water is not an atom, it is a molecule. Only this is the difference. Let's solve some question based on these concepts. Okay, let's solve these questions over here. Questions ask is calculate the number of atoms. First question asked over here is in zero point 0.5 mole of atom. Okay, in zero point 0.5 mole of atom, I'm solving this question. So here 0.5 mole of carbon atom. See, whether it is a carbon atom, nitrogen atom, any kind of atom, zero point 0.5 mole will be what? 0.5 mole will have how much? That is what we need to find. Like whether it is notebooks, whether it is, when we say 1 dozen, uh, that definition of the 1 dozen is not only for apples or mangoes. It can be used anywhere, right? 1 dozen, I can say apple, mangoes, or I can say notebooks, pens, cars. I can count with this. So mole is something which I can use for any kind of atom, any number of atom. But it is a standard relation. So calculate the number of atoms in zero point 0.5 mole. So again, forming a standard relation means what is 1 mole is equal to? 1 mole is equal to this, in 1 mole of any substance. Okay, even if you don't know the atomic mass, doesn't matter. In 1 mole of any substance, 1 mole of if I say 1 mole of carbon atom, then it is 6.022 into 10 to 23. It could be anything, not only carbon, it could be a nitrogen. 1 mole of H2O, then it is 6.023 into 10 raised to molecules of H2O, right? It is that way. So 1 mole is equal to 6.022 into 10 raised to power 23 atoms, right? So this is a standard relation. So how many are present in zero point 0.5 mole? Whether it is a sulfur or whether it is a carbon, sulfur, anything, This relation is going to remain constant, no? 0.5 will have x moles. So x mole atoms, I'll write. So by doing a cross multiplication, what we get x into 1 is equal to 6.023 into 10 raised to power 23 multiplied by 0.5. So what is x is equal to? You multiply this, you will get 3. This is 2 don't get that. 3.011 into 10 raised to power 23. These many atoms are there, atoms of carbon. It is like this question is similar to like I show you I say that there are 48 apples, or um, I say that there are 4 dozens of apple. In there is one box, there are 4 dozens of apple. So how you will calculate how many apples are there in 4 dozens? We know that one dozen is equal to 12 apples or 12 units, right? So 4 dozens means how many apples? Right? Question is how many apples are there in 4 dozens? 4 dozen means x apples or x units. So x will be is equal to what? 12 into 4, which is equal to 48. Right? It is the same similar kind of thing. So going to for a next question. Going for a next question. Next question is this. 3.2 gram of sulfur. See, molar mass or the atomic mass of sulfur is equal to 32. This weight will be given to you. All these weights will be given to you. Don't worry. Don't have to by heart any of the molar masses. Okay, you have to know the like this should be supplied to. So this is what 3.2 gram of sulfur. How many atoms are there in 3.2 gram of sulfur? Say I'm telling you the atomic mass of sulfur is 32 grams per mole. So 32 grams, calculate the number of atoms. The whole question is calculate the number of atoms in this. So 32 gram has how many? You can understand this. I am forming a relation. 32 gram has how many atoms? 6.023 into 10 raised to power 23 atoms. So 3.2 gram will have how many? X number of atoms, X atoms. So X into what? 32 is equal to 6.023 into 10 raised to power 23 multiplied by what? 3.2. Therefore, X will be is equal to what? 6.023. See, again, I will be using this term 2322. Okay, so 23 is also fine, but as per the Goa board, we take this to be 2 only. So better take 2 This is 32. So therefore x is equal to what? 6.022 into 10 raised to power 23. 3.2 divided by 32. Oh, what you will do for this big calculation? It's very simple. Don't get scared for this kind of thing. You can obviously change this, the top one to be 32 into 10 raised to minus 1. You can write this. Like in the previous classes, you used to do multiply by 10, divide by 10. It is a similar kind of thing. You're writing this 32 into 10 raised to minus 10, 10 raised to minus 1, and this is 32. This and this will get cancelled. So it is x is equal to 6.022 into 10 raised to power 23 minus 1. So 22 atoms are there. Okay, this is the thing. Next is 0.2 moles of glucose, right? 0.2 moles of glucose. One molecule, you can see this over here. I'm solving this 0.2 moles of glucose. Um, First, we'll find how many molecules are there. Then we'll find the atoms. So one molecule has how many atoms? One molecule of one molecule of glucose has how many atoms? It is 6 into 1, right? Or I'll write this way. Y1. There are 6 carbon atoms, 6. There are 12 hydrogen atoms and 6 oxygen atoms. So how much it is? 24 atoms, one molecule. So if we get the number of molecules, we will easily able to find the what is the number of atoms. So here, 1 mole has how many atom? 1 mole has how many molecules? Since it is a glucose molecule, 1 mole molecule will have how many? 6.023 into 10 raised to 23 molecules, right? So 0.2 mole molecule will have how much? X molecules. So this is the relation between a mole and a molecules. So what is this? X into 1 is equal to 6.023 into 10 raised to power 23 multiplied by 0.2. So X is equal to what? 6.022, 23 or 22. See, like I am using this 23 only most of the times. So that's why this. So this is 10 raised to 23. This 2 could be written as 0.2 could be written as 2 into 10 raised to minus 1. So now you multiply this 2 and this 12.044 into 10 raised to 22 molecules are there in 0.2 moles. So one molecule means what? One molecule is having how many? 24 atoms, no? So these many molecules will have how many atoms? You will multiply like two molecule will be having 2 into 24 you would have done. Three molecules then you would have done 3 into 24, right? So you will just multiply that. Therefore, number of you can also use a cross multiplication over here, but I don't want to give that again and again. Cross multiplication. Number of atoms atoms in 12.044 into 10 raised to 22 molecules is equal to what? 12.044 into 10 raised to 22 into 24, right? So it is how much? It is so answer is coming to be equal to 289.056 into 10 raised to 23 molecules, right?